Once again back to my YouTube channel Sri Ram Devarajan. Today I am going to solve another set of problem from KSET Mathematical Science question paper from the year 2024. This is part 3. Already I uploaded part 1 and part 2 in my YouTube channel. You just check it out in my playlist. You may get part 1 as well as part 2. Today the problem discussion. The first one is, which of the following is not uniform continuous on the open interval 0, 1. First option e power x, second one cos x, third one sin x, fourth one 1 by x. From the following 4 options, we have to check whether which one is not uniform continuous on the open interval 0, 1. Solution: let f of x equal to e power x, open interval 0, 1. Find limit x tends to 0 plus f of x, which is equivalent to limit x tends to 0 e power x, which is equivalent to e power 0, 1. Find limit x tends to 1 minus f of x, which is equivalent to limit x tends to 1 e power 1, which is e. Both limits exist. Finitely. First option uniform continuous for the option 1. Similarly, for the second option, f of x is cos x. The same method, same manner, find limit x tends to 0 plus f of x, which is equivalent to limit x tends to 0 cos x, cos 0, 1. Limit x tends to 1 minus f of x, limit x tends to 1. Here f of x is cos x, cos 1 exists. Both exist. Finitely. Option 2 also uniform continuous. Now option 3, what is f of x? Sin x. This is option 3. Same manner, find x tends to 0 plus f of x, limit x tends to 0 sin x, sin 0, which is equal to 0. Limit x tends to 1 minus f of x, limit x tends to 1 sin x, this is sin 1 exists. Here also both exist. Finitely. Option 3 also uniform continuous. Obviously option 4 is the correct option for proving not uniform continuous. You have to check for option 4. What is f of x 1 by x limit x tends to 0 plus f of x limit x tends to 0 1 by x 1 by 0 which is equal to infinity not exist. Since the limit value is not exist for f of x which is equal to 1 by x, therefore option 4 not UC. For this problem, fourth option is the correct option. Second problem, let T be a linear operator on R square defined by T of x comma y 2x minus 7y comma 4x plus 3y, then the matrix representation of T relative to the basis B which is equal to 1 comma 3 2 comma 5 is option 1 2 minus 7 4 3. One 21 201 minus 70 minus 116, second option. Third option 24 minus 73, fourth option 121 201 70 116. T is defined by T of x comma y which is given as 2x minus 7y comma 4x plus 3y. We have to find a matrix representation of T with related to the basis B 1 comma 3 2 comma 5. You have to check which option is the correct option for this problem. Since T x comma y 2x minus 7y 4x plus 3y. Also B basis is given as 1 comma 3 2 comma 5. Find T of 1 3. 2 into 1 minus 7 into 3 comma 4 into 1 plus 3 into 3. Answer is 2 minus 21 4 plus 9 13, which is given as minus 19 13. Similarly, find t of 2 comma 5. 2 into 2 minus 7 into 5, 4 into 2 plus 3 into 5. 4 minus 35, 8 plus 15, minus 31, 23. Now write minus 19 comma 31 as linear combination of alpha times 1 comma 3 beta times 2 comma 5. Minus 19 equal to alpha plus 2 beta, 13 equal to 3 alpha plus 5 beta. Solving these two equations, get the value for alpha and beta. Multiply first equation by 3. Minus 57, 3 alpha, 6 beta, 13, 3 alpha plus 5 beta. Solve these two equations. Minus, minus, minus. Minus 70, which is equivalent to beta. Beta nothing but minus 70. Now find the value for alpha. Minus 19 minus alpha, which is equivalent to do beta, minus 19 minus 2 beta alpha, minus 19 plus 140 equal to alpha, alpha equal to 121. Similarly, write minus 31 comma 23 linear combination of alpha times 1 comma 3 beta times 2 comma 5 minus 31 alpha plus 2 beta 23 3 alpha plus 5 beta. Equation 3, equation 4. Multiply equation 3 by 3. Minus minus 93 3 alpha 6 beta 23 3 alpha plus 5 beta. After solving, minus 93 minus 23 minus 116, which is equivalent to beta. Now find the value for alpha. Minus 31 minus 2 beta, which is equivalent to alpha, minus 31 minus of 2 times minus 116, which is equivalent to alpha, minus 31 plus 232, which is equivalent to alpha, alpha equal to 201. Therefore, matrix representation of T is, write the value in column, alpha 121, beta minus 70. 121 minus 70. Here alpha 201, beta 116. For this problem, option 2 is the correct option. Third problem, the nth iterated kernel K3 of x comma t of y of x, which is equivalent to 5x plus 6 plus 1 by 2 integral 0 to 1 x of t y of t dt is first option 1 by 6 xt, second option 1 by 9 xt, third option 1 by 27 x square t, fourth option minus 1 by 9 xt. The problem is from a integral equation. The problem based on Fredholm integral equation because both the limits are constant. Solution. For this problem we have to find K3 of x comma t. Among the four options, which one is the correct one? Given what is y of x? 5x by 6 plus 1 by 2 integral 0 to 1 x of t y of t dt. This is equation 1. Comparing 1 with y of x f of x plus lambda 0 to 1 k x comma t y of t dt, lambda 1 by 2 f of x 5x by 6 k x comma t xt. Let k n x comma t be the nth iterated kernel, then k1 x comma t is k x comma t, here k x comma t is xt, k n x comma t integral 0 to 1 k x comma z k1 z comma t dz. From this find k2 x comma t 0 to 1 kx comma z, sorry here not k1, kn minus 1, k1 z comma t dz. This is nothing but k of x comma t is xt, k of x comma z xz, k1 of z comma t zt dz, xt integral 0 to 1 z square dz, xt z cube by 3 0 to 1 xt by 3 into 1 minus 0. Answer is xt by 3. This is k2 of x comma t, but we need k3 of x comma t. k3 of x comma t integral 0 to 1 kx comma z, k2 z comma t dz, integral 0 to 1, this is xz, zt by 3 dz, this is xt integral 0 to 1 z square dz, xt by 3 z cube by 3 limit 0 to 1 xt by 9 into 1 minus 0. Answer is xt by 9. This is k3 of x comma t. For this problem, second option is the correct option. Problem number 4. The extremal of integral 0 to pi by 2 y dash square plus z dash square plus 2yz into dx with the condition y of 0 equal to 0, y of pi by 2 equal to 1, z of 0 equal to 0 and z of pi by 2 equal to minus 1. First option, y equal to cos x, z equal to minus cos x, y equal to e power minus x, z equal to cos x. Third one, not existing. Fourth one, y equal to sin x, z equal to minus sin x. The problem is from a calculus of variation. The extremal of integral 0 to pi by 2 y dash square plus z square plus 2yz dx with the condition y of 0 is 0 and y of pi by 2 equal to 1, z of 0 is 0, z of pi by 2 minus 1. Functional is given, we have to find the extremal for this functional with this condition. Out of the 4 options, which one is the correct one? Here, what is f? Y dash square plus z dash square plus 2yz. Euler Lagrange equation is fy minus d by dx of fy dash equal to 0. Equation A, fz minus d by dx of fz dash equal to 0. Equation B. Fy means 2z minus d by dx of 2y dash equal to 0. Fz 2y minus d by dx of 2z dash equal to 0. Therefore 2z minus 2y double dash equal to 0, y double dash equal to z. Similarly 2y minus 2z double dash equal to 0, 2y equal to 2z double dash, z double dash equal to y. From these two, we are having two equation. One is y double dash equal to z and second one is z double dash equal to y. These two are second order differential equation. Y double dash equal to z, but z double dash equal to y. Y power 4 equal to z double dash, which is equal to y. Y power 4 minus y equal to 0. Auxiliary equation m power 4 minus 1 equal to 0. We can write it as m square minus 1, m square plus 1 equal to 0, m square equal to 1, m square equal to minus 1, m equal to 1 comma 1, here m equal to plus I comma minus I. Here m square equal to 1, m equal to plus 1 minus 1. Here m equal to plus I minus I. Therefore y equal to c1 e power x, c2 e power minus x, c3 cos x, c4 sin x. What is y dash? c1 e power x, c2 e power minus x, minus c3 sin x, c4 cos x. What is y double dash? c1 e power x, c2 e power minus x, minus c3 cos x, minus c4 sin x. Since y double dash is nothing but z, this is z. We find out for y, here we are find out for z. This is y equal to c1 e power x plus c2 e power minus x plus c3 cos x plus c4 sin x. This is z, which is equal to c1 e power x plus c2 e power minus x minus c3 cos x minus c4 sin x. Now apply the condition. X equal to 0, y0 z0. This is 1, this is 2, from 1 and 2 0 equal to C1 plus C2 plus C3. 0 equal to C1 plus C2 minus C3. Solving, we get 2C1 plus 2C2 equal to 0. C1 plus C2 equal to 0. It is possible only C1 0, C2 0. C1 0, C2 0 means what will happen to C3? C3 must be 0 because C1 0, C2 0. Now the second condition, x equal to pi by 2, y equal to 1, z equal to minus 1. From 1 and 2 we get C1 e power pi by 2, C2 e power minus pi by 2 plus C4 equal to 1. From 2 C1 e power pi by 2 plus C2 e power minus pi by 2 plus C4 equal to minus 1. Solving these two, we get these two cancel, 2C4 which is equal to solving, we are getting 2C1 plus 2C2 equal to 0 divided by 2, C1 plus C2 0. It is possible only C1 and C2 must be 0. If C1 and C2 0, C3 is 0. Now applying the second condition, when x pi by 2, y is 1, z equal to minus 1, we are getting these two equations from 1 and 2. If you subtract these two equations, we are getting 2C4 equal to 2, C4 is 1. Since C4 is 1, C1 e power pi by 2 plus C2 e power pi by 2 plus 1 equal to 1, C1 e power pi by 2, C2 e power minus pi by 2, it is equal to 0. Both e power pi by 2, e power minus pi by 2 not equal to 0. Therefore, it is possible C1 0, C2 0. In this problem, we are getting C4 1, C3 0, C1 0, C2 0. Substitute the values of C1, C2, C3, C4 in y, in z. I am getting minus C4 sin x. Since C4 is 1, that is y equal to minus sin x. Z equal to C4 sin x. Here C4 is 1, Z equal to sin x. For this problem, option 4 is the correct option. Fifth problem. B the general integral of xpq plus yq square equal to 1 is given by 2z plus b whole square equivalent to 4ax plus y 2z plus b whole square equal to 4 times ax plus y. Third option, z plus b whole square equal to 4 times ax plus y. Last option, z plus b whole cube equal to 2 times ax plus y. This problem is from PDE. We have to find the general integral for xpq plus yq square equal to 1. Let us take given equation xpq plus yq square equal to 1 as f. F equal to xpq plus yq square minus 1. For this PDE, I am going to use Chorpitch method. Auxiliary equation for Chorpitch method is the auxiliary equation for Chorpitch method is dp by fx plus p fz dq by fy plus q fz dz by minus p fp minus q fq dx by minus fp dy by minus fq. This is actual equation if you apply Chorpitch method. From f, find fx. This is pq. Find fy, which is equivalent to q square. Find fz. Fz is 0. Find fp, which is equivalent to xq. Find fq, xp plus 2yq. Substitute all this value in equation 1. dp by pq plus p into 0 dq by q square plus q into 0 dz by minus p into xq minus q into xp plus 2yq dx by minus xq dy by minus xp minus 2yq. From the first two ratio, we are getting dp by pq dq by q square, which implies dp by p dq by q integrating log p log q plus log a. A log a is the constant of integration. This can be written as log of aq, which is equivalent to log p. What is p? P is aq. Since p is aq, from xpq plus yq square equal to 1, we may find the value for q. X into aq into q, yq square equal to 1, q square xa plus y equal to 1. Therefore, q is nothing but 1 by root of y plus ax. We know very well what is dz. P dx plus q dy. What is p? aq dx 1 by root of y plus ax dy. A into again q root of 1 plus root of 1 by root of y plus ax into dx 1 by root of y plus ax dy. This is nothing but a dx plus dy root of y plus ax. This is nothing but ax plus y divided by root of y plus ax. This is dz. Integrating integral d of ax plus y by root of y plus ax. If you take y plus ax sum as some value t, integration of dz is z, integration dt by root t, which is equivalent to t power minus of t, which is equivalent to t power minus of plus 1 by minus of plus 1 2 times t power of 2 times root t. Here z. Since we have to add constant of integration, therefore I am writing z as z plus b. This b is constant of integration. Z plus b is 2 times root t. Z plus b whole square equal to 4 times t, which is equal to, what is t? 4 times y plus ax. Four times y plus ax equal to z plus b whole square. Option 3 correct option. I will upload more problems from KSET 2024 from the Mathematical Science question paper. Subscribe my channel, like my channel, share my channel to your friend. Thank you.